Hello again, everyone. It's time for us to continue our lessons with circles. We did inscribed angles yesterday, inscribed being angles where all 3 points of the angle lie on the circle. That means your vertex also lies on the circle. Today we're going to sort of expand on that into talking about different shapes that we can inscribe. I know we've done area with inscribed shapes before, but this will be a little bit different. We're focusing more on the angles and the arc measures than anything else. So here you're actually going to see a triangle that we dealt with as part of the big circles packet. We did a 45, 45, 90 triangle, said, hey, if I know what the diameter is, then great. And BC, this hypotenuse right here, that's definitely a diameter. It passes straight through the center of this circle. Awesome. And then we said, all right, do your normal divide by root 2 thing to find what this is, what this is. Today we're going to talk about how the angles are affected when we put a right triangle in the circle, and not just a 45, 45, 90. We're not only going to be focusing on that, because depending on where this point D goes, depending on where our angle is that's not on the diameter, if we move it, that might change the value of everything in this triangle. So let's try that. I'm going to take this point D, I'm going to drag it down a little bit further into like this area, and let's see what happens to those angles. Well, as you can see, definitely getting some changes for B and C here. We now have 34 degrees, 55 degrees, but angle D is still staying at 90. I can go all the way over here. Angle D is still going to stay at 90. I can go all the way up in this direction. Angle D is always going to be 90 degrees. So no matter where we put this thing, we're still going to have a 90-degree angle. These two angles may not be the same. They will change from 45 and 45 as soon as we move this point anywhere. But this is because if you have an arc, like say this one over here, this arc is the intercepted arc of angle D. So this angle right here opens up. Please bear with my terrible, terrible drawings. This angle opens up like so, and has this arc inside of it. Well, how many degrees would this arc be? We just said BC was our diameter. That means this is exactly half of our circle. We have a 180-degree arc. And no matter where I take this shape and move it, no matter where point D goes, it's not going to change the fact that, yeah, I'm not on this line and I'm not on this line anymore. But it doesn't change the fact that our arc remains 180 degrees. It's still exactly half the circle on this side of the diameter, no matter where it goes. So if you've got a right triangle that you're dealing with here, that's actually very good news, because that means you just know that these two arcs right here, the two that, could change, could be different, but you do know that they will have to add to equal 180 degrees, the other half of this circle. So we're going to go into a couple of examples with these sort of things, how you might see different kinds of questions that would ask you about right triangles before we move on to our next kind of shapes, which are quadrilaterals. So now we're going to move on to these exercises that I've attached on Classroom along with this video. We're going to start with question number 1, split into 2 different parts that we'll treat separately, but both of them deal with circle A, so A is dead center, and line BC is the diameter of the circle. Now that's important information because, as we just discussed, if you've got a diameter, then you've got something that takes your circle and splits it straight down the middle, splits it in half, which means, yeah, we do have 180 degrees on this entire side. We'll have 180 degrees on this entire side. That might be helpful to us in a second. Which also means any angle that's going around here that forms a 180-degree arc, we know has to be 90 degrees. So we get to actually put in something that's going to help us a lot with this problem if we decide to use the triangle, and that's that this is a 90-degree angle. So let's jump into these two examples. Part A, if the measure, please remember what that little m stands for, the measure of arc BD is 48 degrees. Not saying that this is 48 units long in any way, saying that from here to here is 48 degrees out of the 360 degrees of the circle. So here's what we know. What we're asked to find is the measure of angle B. So we need to know how big this angle here is in order to solve this problem. Well, we've got a couple of different ways we can do this, one involving the triangle, one involving the arcs. We'll start with the arcs because it's something we've just discussed. We said that this diameter splits our circle in half. There's 180 degrees on this side. Well, that means there's 180 degrees on this side too, and if I already know 48 of it is right here in green, then if I want to find what I'm highlighting right now in blue, all I've got to do is subtract. Hey, this whole thing is 180. This is 48 of it. When I subtract those two numbers, I get that this blue arc is 132 degrees. So now I've got the arc on the outside. I just need to find the angle on the inside. I need to know if I go across this circle and hit this angle at point B, which is on the circle, how many degrees would this angle be? Well, you can tell it's not just going to be 132 degrees. There's no way this is 132 degrees if it's in a triangle with a 90-degree angle. But we have a rule for that. We're going across, we're going from our arc to our angle. If we divide that arc in half, take that number and divide it by 2, 132 divided by 2 will give us our answer. That little angle in the corner there is 66 degrees. Now, I did say this was one of two ways to look at this problem, so we'll go over the other one now as well, just so that, it's up to you how you want to approach this problem. So again, we have a 48-degree arc here, and our goal is to find the measure of an angle. But if we know the measure of an arc, we should also know the measure of the angle that forms that arc. Here's the angle at point C when it opens up this way, when it opens up this way. Hey, look, I've got this green arc inside of it. So all I've got to do now is say, how do I know how many degrees this is? Oh, wait, that's literally what we just did with the other example. We cut our arc in half. 24 degrees up here. Well, if you've got 24 here and you've got 90 here, 90 plus 24 is 114 degrees, and 180 minus 114 will also give you a 66-degree angle down here. So two different ways with this triangle that you can work your way around. One of them, well, both of them actually have to involve what we just learned about inscribed angles, though. Either we used this arc to find this angle, or we used this arc, which we were able to find from the 48, to find this angle over here. Okay, so now we'll talk about part B. Again, same circle, same idea, but we're using different numbers here, so I've erased everything else here, just left the 66 degrees, so you remember that answer. And the measure of angle C in this problem, the measure of this angle right here is 17 degrees. We want to know what that means about finding the measure of arc CD. Well, this is the thing we're asked to find, but this green arc doesn't come from that blue angle. It comes from the angle that's over here. Well, we can again say there's two different ways to think about this. One of them is, hey, that's 90 and that's 17, so some quick math will tell me how many degrees has to go over here. And now, if we're going from an angle to an arc, we have to double it. We're going up. We're taking our 73 and multiplying it by 2, not dividing by 2. And when we do that, we will find that this arc should be 146 degrees. Sounds good? Cool. Let's double check our work based on what we had just found about arcs. If this angle is 17 degrees, then the arc down here that this angle forms, as we said, is double that. So this angle, or this arc rather, is 34 degrees. And since our diameter splits our circle in half, we have 180 degrees here, and 180 minus 34 will also give us 146 for this arc right here. So now it's time for us to move on to what we call inscribed quadrilaterals. You can see QUAD right here is an inscribed quadrilateral because all four of those points lie directly on circle S. And we're going to talk about some properties that these sort of things have. And I'm going to start by focusing on two angles at a time, namely the ones opposite one another. So we'll do a little Q&A, pun intended. So I'm going to do the same thing I did before with the inscribed right triangle, and I'm going to trace out, hopefully a little bit better this time, angle Q. which is these two lines right here. And inside angle Q, what I find is that I have this arc going all the way around the inside. So this whole thing, DAU, however many degrees that is, that whole arc fits inside this one angle. Now we know what the relationship is between an inscribed angle and an intercepted arc. If this angle was 90 degrees, for example, this would be a full 180. If it's 100, then this is 200. Let's take a look at the other angle. So here's angle Q up top. Unfortunately, I'm going to have to do the same color right now, but let me trace out angle A. So angle A lives down here, goes up in this direction as well. And the angle that lies inside, the arc that lies inside this angle is this one right here, DQU, that goes all the way around this way. And you'll notice somewhere in between all of the terrible drawings that I've just done, somewhere in the middle of all of this mess, we now have a pair of arcs that together make the entire circle. Well, if we have a pair of arcs that together make the entire circle, then we're actually in great shape because we know that a circle is 360 degrees. And if the circle is 360 degrees, remember what we just said. If I was to take this arc and divide it by 2, I'd get this angle right here. If I was to take this arc on this side, divide it by 2, I'd get this angle. We just said those two arcs combine to give you 360 degrees, so that means that these angles across from one another will always have to add to equal 180 degrees. Think of it this way. If this angle up here is 100 degrees, then the arc down bottom on the outside would be 200 degrees. We want the entire outside of the circle. Well, we know what 360 minus 200 is. We'd have to have 160 degrees here. We'd divide that by 2 and we'd find that this angle is 80 degrees down here. So that's a nice rule that we're going to have for all of these quadrilaterals when we inscribe them within the shape. That if you have all of this different things here, if you have 4 points on the circle and you want to talk about angles and arcs, well, the angles across from one another have to add to equal 180 degrees, and we'll go into a couple examples of how the rest of this will work out as well. So now going back to our exercises, we see question number 2 here. This time again, circle S. Again, QUAD is our inscribed quadrilateral. All I've done is move these letters to different places, but same idea. We've got a 4-sided shape inside this circle. All 4 of the corners of that shape are on the circle, and we want to answer a few questions. Now, compared to the right triangles we had up top, it looks like we have a lot more information. We have a 57 degree and 22 here, so 2 pieces of information that we're given. Down here, we have 3 pieces of information that we're given. So hopefully we're going to find that to be easier, but it just depends on how that information helps us. So, part A, the measure of arc DQ is 57 degrees. The measure of arc AD is 22 degrees. So we're given 2 things about the outside of the circle, essentially. So we know these 2 numbers. We are asked to find the measure of angle D. So this whole angle right here that has point D at its vertex, that's not being helped by these arcs that are behind it, though. We care about the arcs that would be across from it. So we could try to figure out what that means about these 2 arcs over here. Or we just came up with a rule. We said that we know that the angles across from one another in a quadrilateral, when it is inscribed in a circle, always have to add to give you the same number, 180 degrees. So that means if only we knew about this angle that meets at point O, if only we knew how many degrees that was, we'd just be able to do 180 minus this number and find what we have left. Luckily for us, if I erase all the mess in here, you'll see, hey look, when this black angle opens, it's got both the red and the blue arcs inside of it, and that's it. So all I've got to do is some quick math here. 57 plus 22 means that this entire arc from here to here is 79 degrees. Again, if we want to find an angle based on the arc, we've got to go back across the shape. We're dividing by 2. 79 divided by 2 does mean we're going to have a decimal here, guys. Don't freak out when it happens. This angle is 39.5 degrees. And it's not going to change how we find the thing that we're asked for at the end. We know that the angles across from one another are supplementary. They add to 180. So 180 minus this number right here will give us how many degrees this angle over here was. So 140.5 degrees will give us our answer for part A, 140.5. You will have decimals as part of your answers, especially on the IXL exercises, so please don't freak out when that happens. So now we'll move on to part B, finish this off. Again, we were given 3 angles, which is a good amount of information, so hopefully we're not unhappy about that. Angle Q right here is 73 degrees. Angle U, right side, is 42 degrees. And the measure of arc AD, so little arc right here, is 19 degrees. From this information, our goal is to find the measure of arc QU, this one all the way on the other side. Now, if we wanted to talk about an arc over here, we'd need the angles that are over here, but angle D, when it opens up, includes both this highlighted arc and arc AU down here. When angle A opens up, it includes the highlighted arc and arc DQ. So there's a lot of work that would have to go into it. We do know what these 2 angles would be if we know our 180 rule across from one another. But we're going to do this a slightly different way. We're going to work with the angles that we have to find the arcs that we don't know yet. So we're going to start with angle Q as our first given. And this angle was 73 degrees. When angle Q opens up, it forms an arc that goes around, ooh, fancy colors, from point D to point U. So arc DAU, if we wanted to name it with 3 letters. And we should know how to get there, right? We have a 73 degree angle here. When we want to find the arc that it makes, we take that angle and we double it. So this whole arc in multicolored goodness is 146 degrees. But it overlaps with this 19 degree arc that we know over here as well, which means we've still got to do one last piece of math here with this measure. We've got 146 for the whole thing. We're going to take that 146 and subtract 19 from it. And 146 minus 19 would give us how many degrees just this arc from A to U is. This is 127 degrees. Well, if we could do that with angle Q up top, we can certainly do that with angle U on the right. This 42 degree angle, when it opens up, forms this arc right here. We take our 42 to go across, we double it. We find that this arc is 84 degrees, the entire thing. But again, it includes this 19 degree piece of it, which means if we want to know just what's left over, just what this arc right here would be from D to Q, we're doing that 84 and we're subtracting 19. And 84 minus 19 means that this arc is 65 degrees. So now, as we look around here, we've got one arc that we know here, we've got a second arc that we know here, we've got a third arc that we know here. We need to know the fourth arc. And if we want to find the fourth piece of our circle, but we know the other 3, all we have to do is make sure we add stuff together. You have 1, 2, 3 angles here that need to be added. Well, good news, we just said 65 plus 19 was 84, so all I've got to do is 84 plus 121. Once we get that answer, once we get 211 degrees, that's how many degrees this highlighted arc isn't. Well, how are we going to find what it is? That's going to be our last step. We know that a circle has 360 degrees in it. If we subtract the number of degrees of the arcs that we know, we're going to find the degrees of the arcs that we don't. And 360 minus 211 tells us that that remaining arc is 149 degrees. So, Again, a couple of different ways to approach these problems, going from angles to arcs. So this doesn't change what we learned in the last lesson. It's just taking it and giving you a few more tricks. So again, angles across from one another add to 180. We can still do the doubling an angle to find the arcs, and we can use all four of our arcs at the same time to find a piece that's missing. So that does it for the lesson part of today's lesson. You'll have questions on Khan Academy, you'll have questions on IXL, so please make sure you look through Classroom, see what those assignments are, and make sure you complete them in time. Thanks, guys. Take care.